A deep dive into scikit-learn's Gaussian process. What is a Gaussian process? In essence, a Gaussian process (GP) is a statistical model that defines a probability distribution over functions. Instead of modeling a single function, a GP models a whole family of functions. This means that for any set of input points, the corresponding function values are assumed to follow a joint Gaussian distribution. Key concepts. Before observing any data, a GP has a prior distribution over functions. This prior captures our initial beliefs about the possible functions that could represent our data. Likelihood. The likelihood function describes the probability of observing the data given a particular function. Posterior. After observing data, the GP updates its prior distribution to form a posterior distribution. This posterior represents our updated belief about the functions, taking the data into account. Why use Gaussian processes? GPs offer several advantages. Non-parametric. Unlike many traditional methods, GPs do not make strong assumptions about the underlying function. This makes them adaptable to complex and unknown relationships in the data. Smoothness. GPs naturally produce smooth functions, which can be helpful for interpolation and prediction. Uncertainty. Quantification. GPs provide an estimate of uncertainty in their predictions, which is valuable for decision making. Key components in scikit-learn's Gaussian process implementation. sklearn. Gaussian process. 1. Kernel. The kernel function is the heart of the GP model. It defines the covariance between function values at different input points. The choice of kernel determines the smoothness and other properties of the resulting function. Popular kernels. RBF radial basis function. The most common kernel. It favors smooth functions and is suitable for interpolation and prediction. Linear kernel models linear relationships between input and output. Polynomial kernel can capture polynomial relationships between input and output. Matern kernel offers control over the smoothness of the resulting function, with different parameters leading to varying degrees of smoothness. 2. Gaussian process regressor. Gaussian process regressor. This class implements Gaussian process regression. It uses the chosen kernel to learn the relationship between input and output, and then predicts new outputs for unseen inputs. 3. Gaussian process classifier. Gaussian process classifier similar to the regressor, but designed for classification problems. It uses a kernel to learn the decision boundary between classes and predicts the class label of new data points. Essential parameters in sklearn. Gaussian process. Kernel. The kernel function used to model the covariance between function values. Alpha. The noise level added to the diagonal of the covariance matrix. This regularizes the model and prevents overfitting. N. Restarts optimizer. The number of times the optimizer is run with different initial values. This helps find a better global optimum. Optimizer. The optimization method used to find the optimal hyperparameters of the kernel. Practical applications. Regression. Predicting continuous values like stock prices, temperature, or material properties. Classification. Classifying data points into different categories, such as spam detection, medical diagnosis, or image recognition. Interpolation. Estimating function values at points where no data is available. Bayesian optimization. Optimizing complex functions by efficiently searching for the best parameters. YAML. Example explained. YAML. Kernel. Type RBF. Length scale 1.0. Length scale bounds 1 EO5. 10.0. Alpha 1 E-10. N. Restarts optimizer 10. Optimizer FMINLBFGSB. Kernel. Type RBF. Specifies the radial basis function kernel. Length scale sets the length scale of the kernel, which controls the smoothness of the resulting function. A smaller length scale leads to a more wiggly function, while a larger length scale produces a smoother function. Length scale bounds defines the bounds within which the length scale can be optimized. Alpha sets the noise level, which can be adjusted to control the balance between fitting the data and avoiding overfitting. N restarts optimizer indicates the number of times the optimization procedure is restarted with different initial values. Increasing this value may help find a better global optimum, but it also increases computation time. Optimizer specifies the optimization algorithm used to find the best hyperparameters of the kernel. In this case, it's using the LBFGSB algorithm. Conclusion: Gaussian processes are a powerful and versatile tool for modeling functions and making predictions. The flexibility of their non-parametric nature, combined with their ability to quantify uncertainty, makes them well suited for a variety of applications. By understanding the key components and parameters of the Gaussian process regressive and Gaussian process classifier classes in scikit-learn, you can effectively implement and customize these models for your specific needs.